Hello Sunny with brilliant people, how are you today? So today I'm going to discuss about problem number 12.6 of atoms chapter grade 12 physics, and this is one of the NCERT textbook problem. So what we are being given over here is we have a hydrogen atom initially at a ground level. That means ground level means we have orbit number 1 and this is an hydrogen atom, and we know that the energy formula is minus 13.6 z square upon n square, where z is the atomic number and n is the orbit number, right? Energy of the nth orbit. So if I substitute z as 1, as hydrogen as atomic number 1, and n as 1, I get the energy as minus 13.6 eV. Now an electron is over here. Now this electron absorbs one photon, so it is absorbing one photon, and after absorbing this photon it goes to n is equal to 4. Now if I substitute n is equal to 4 over here, that means the energy would be minus 13.6 upon 4 square, that is 13.6 divided by 4 square is 16, so it is 0.85, so it would be minus 0.85, correct? That is the energy of the fourth orbit. So this photon should be of energy of difference in these two. So an electron, if it wants to go from here to here, it must absorb the energy which is equal to the difference in these two. So this photon must be of the energy whose energy is equal to the difference in these two orbits. So if we find the 13.6 minus 13.6 minus 0.85, we get 13.6 minus 0.85, that is 12.75. So that means this photon should be of energy 12.75 eV, correct? So this electron is going to absorb this photon and then it is going to go to this higher energy orbit, right? And they are asking us that determine the wavelength and frequency of the photon, correct? Okay, this could have been this question could have been asked in the another way as well, that if this electron directly falls down to first orbit, then the energy released is in form of photon, and that photon will also have the same frequency and wavelength. So they could also ask you to find out the frequency and wavelength of the same photon, correct? So here we know that this E4 minus E1 is the difference in the energy that should be received by this electron to go here, and that should be provided in form of the photon, and photon must have energy this, and photon actually has got energy hc by lambda, correct? So now we know that the energy of the fourth orbit is minus 13.6 1 square upon 4 square minus 13.6 1 square upon again 1 square, that is equal to hc upon lambda, correct? So now let's substitute the value. We know this is 0.85 minus of minus 13.6, that is equal to h, we know it is 6.62 into 10 raised to minus 34, and this is in SI unit, guys, and this all energies are in electron volts, so you must be very careful that these energies are not in joules, correct? And this side is in SI unit, so this is in 3 into 10 raised to 8 meter per second upon lambda is what we are supposed to find out, and I must be careful that this is 12.75, but this is in EV, and we know that 1 EV is equal to 1.6 into 10 raised to minus 19 joules. So since everything is in SI unit, so I need to convert this also in SI unit. So 12.75 into 1.6 into 10 raised to minus 19, that is 6.62 into 10 raised to minus 34 into 3 into 10 raised to 8, correct? So let me take this lambda over here. So when this lambda goes over here, that is equal to 6.62 into 10 raised to minus 34 into 3 into 10 raised to 8 upon 12.75 into 1.6 into 10 raised to minus 19. So guys, if you solve this, you will get your answer as 9.74 into 10 raised to minus 8 meters. So this is our wavelength of the photon which is required to excite this electron from 1 to 4. Correct? Now, how can we find out the frequency? Very easy. For any electromagnetic waves or for any waves, F into lambda, that is equal to C. So now since we know lambda, frequency shall be equal to C upon lambda, where C is 3 into 10 raised to 8 meter per second. Lambda is what we have already found out, 9.74 into 10 raised to minus 8. So if you solve this, SI unit would be, this is in meter, so meter getting cancelled, 1 upon second is hertz. So if you guys solve this, you will get your answer as 3.08 into 10 raised to 15 hertz. So let me mark these two answers. This is our first answer and this is our second answer.